Me.
La 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 la. All right, let me know whenever you're ready.
We were rolling.
All right, so today we're going to be talking about...
Can I start that over?
Yeah, I'm kidding. I already screwed up.
It's going to go real good.
All right. So today we're going to be talking about battery management systems, also known as BMSs. Basically, that is what controls and takes care of your battery systems inside these vehicles. A common misconception, I think, in this industry, in all industries that use batteries, is they think a BMS is just basically a balancer, something like this that balances your cells. Our definition and the true definition of this is a little bit differently. This is only one component of many components that actually manage your batteries. So that's what we'll be talking about today. That's what we're going to go over, and all the different components that actually make up a true BMS. Back to you, Snow.
All right. Well, one of the things that Eddie B pointed out is that if you were to go online and you looked up BMS, the first thing that would come up is a module very similar to what he just had in his hand. But again, like he said, that's only one component of the BMS. So I definitely think it's a good idea to inform, especially the do-it-yourselfers, on what it takes to actually put together a battery management system.
Yeah, so first thing we want to kind of start with is, we want to make sure that we know what's going on inside the batteries. So we will start with cell monitoring. So cell monitoring systems are anything that basically looks at what you're doing, looks at the batteries, and reports that back to the user. Either records the data, tracks the data, and visually displays that to you so you know your cell health, your charge, your state of charge, how deeply you dove into the pack, your discharge rates. There's a lot of different things here, and they all amount to one thing, is safety. So the reason these systems are actually in place is for safety. The types of battery chemistry that we use in most of these EV builds is like a lithium iron phosphate or lithium polymer, or any kind of blend of a lot of those types of chemistries, and they are very volatile to going up in flames, especially during the charge. When you bring these batteries up, they tend to heat up. If you overcharge them, they will catch on fire. If you discharge them too far, they will start degrading on you, and you'll basically be chewing through your batteries pretty quickly. So once again, having cell monitoring is a very, very big part of this. You want to make sure that it is being reported, recorded, and then what you do with that data, you could adjust parameters to make sure you don't overcharge, over discharge. We had a couple incidents here in the shop where Snow's truck didn't have a proper monitoring system on it. He took off and drove his truck down the street, and all of a sudden you're on the
Went
side
to
of
limp
the road.
mode.
Yep. Pretty easy to get into trouble. Yeah.
Yeah, and unfortunately that battery pack is something that we don't have very many over at our back office sitting here.
We don't have an abundance of those.
No, and once that happens, once, twice, you start to degrade the battery life and the capacity as well of those things. So you want to make sure that you do have warnings put in place, and you are actively monitoring your cell health. Also, a big thing with cell health is monitoring your temperatures. We know what happens when these things get hot; they catch on fire, and that's a very, very big thing. And before we started today, we're talking about cold temperatures. Do you want to touch on that?
Yeah.
Especially where you come from.
Yeah. So here in Southern California, we're pretty fortunate. We're in kind of the happy zone for these batteries most of the year. But people out in like Arizona or Alaska are going to need some kind of battery cooling or battery heating to keep them in that safe, happy range. And it's not just safety as well. Because if you're running these batteries up near the top of their temperature limit or at the bottom of their temperature limit all the time, your lifetime of those batteries is going to decrease pretty dramatically.
Yeah, one of the things too we noticed, there is a finite of happiness of where these batteries like to sit. Typical lithiums, they're like us. I like 70 degrees, 75 degrees Fahrenheit, and I don't like to deviate off of that too much. If you start getting north of that, or really down in the very cold, your battery is going to perform very differently. Kind of going to some of the racing that we've done at Bonneville, there are two big races at Bonneville that we do. One of them is in extreme heat, and it's usually over 100 degrees Fahrenheit outside, and we are really closely monitoring those batteries to make sure they don't get too hot. We raced in October. I think it was 2 months after.
Got pretty chilly.
Yeah.
And it was, what was it, low 40s, high
was,
30s.
It was high 30s, low 40s, and typically what you do if you beat a record, it's not official until you come back the next day and back it up. Well, if you do that, you break a record, beat a record, then they take the car to what's called impound, and then it has to stay there until the following morning. Well, since you're in impound for a record, you have priority at the line the next day. But the problem with that is, for an electric vehicle, right, the batteries are cold, so you need to heat your batteries up to a nominal temp so that you can actually race and get the performance out of the batteries. Well, that's one of the things that your battery management system comes into play, and it will tell you when and if you're ready to run.
Yeah, and that's what these Teslas do. And when they're running their ludicrous mode or their launch mode, they'll heat the batteries up to their prime kind of peak power producing temperature. There is definitely a curve on that.
And now, so since you mentioned that, a couple of things, industry terms that we want to make people familiar with, and one of them, your battery management system, the primary purpose is to manage and monitor your state of health on your battery pack. The other primary function is to manage your state of charge. So state of health, state of charge, two terms we're going to probably be referring to for the rest of this training.
And temperature is one big thing too. I can't jump into and jump all over that more. It's just, that is huge. These things are very, very sensitive to temperature. Back to the bondable thing, our pack had to be heated up and make sure it stayed warm, because at the very bottom, these things, when they get cold, they don't produce any power. And it's a real strain on the systems, and you're damaging your batteries. So once again, we're talking about battery management, which is everything. It's not just balancing your cells, but it's everything from balancing your cells all the way to using temperature to either get things colder or warmer, monitor your state of charge, your battery health, also power distribution, communication between your batteries and your computer systems, data logging, alarms, and at the very end, fire mitigation, because there are going to be instances that we are uncontrolled. We have no control over. Basically, accidents. It happens. People get in crashes every single day. What have you done to make sure to prevent those things from killing or injuring somebody inside the vehicle? So that, to me, is a battery management system, not just balancing. So we're going to cover all of that. Kind of the second thing here I want to jump into is battery protection. This is also a big part of battery charging. So basically, when you are trying to make sure that you're not going over limits or under certain limits, over currenting, things don't like to charge very fast. We hear supercharging at Tesla all the time. They have a very, very good system. Their battery management systems take care of everything from heating to cooling to monitoring charge rates. When I go to the charger with my Tesla, when it's really cold outside in the morning, that thing does not charge very fast. It kind of waits for the battery pack to heat up. Also, when it gets to the top, things start to slow down as well. So battery protection is a big thing. You want to make sure that you're always monitoring those things, and having a good data logging or interface so you know what's going on is very important. A lot of people plug in these BMSs and they forget about them, and they don't really know what's going on. So make sure that you are looking at those things and making sure you're paying attention to what's going on there. Anything you guys want to add on battery protection?
I think they pretty much covered it.
Yeah.
Okay.
Yeah.
So charge control. It is very crucial to make sure that everything's being charged on its correct rate. A lot of us DIY guys do use different types of cells. C rating is a big one. Just because the battery could discharge at a certain rate doesn't mean it could charge at a certain rate. Luckily for this industry, I should say, there's not too many DC to DC fast chargers going on.
True.
Most of us are still like at the 6.6 kilowatt level, which on a big pack isn't going to cause that many problems because you're not pumping that much into it very quickly. But still, again, we come off a racetrack, our batteries are nice and hot, and now all of a sudden you're charging them. Be very careful. You want to make sure you're monitoring your temperatures and your currents too. So a good BMS will monitor, or a BMS module that actually is the brains behind that, will make sure that things don't hit certain limits, and you could program. We have a lot of BMSs in front of us right now. One of them is from AEM. Their system's pretty elaborate. I'd say it's probably the most elaborate we've seen
I'd
so
say
far.
so.
Yeah.
It can throttle in all these conditions. So if your battery's too cold, it'll throttle. If your battery's getting whatever it is, it's got the brains to not put your battery in an unsafe situation.
Yeah,
And then that comes kind of back to your initial statement. As you said, the battery management system is not just one module. So in that situation, if you wanted to charge and it needs to charge quicker or slower, the battery management system will communicate that to your VCU, which in turn talks to your controller, and the charge controller will actually throttle back, speed up your charging, and help you manage your battery pack and keep it at a safe level.
Yeah. One thing too is power distribution. This is something that I've seen quite often done incorrectly. When I say power distribution, I mean how you get your power between one module to the next module. I'm going to use our 400 volt system that we have here at Revolt for all of our motors. We need 96S. That means 96 batteries in series of a 3.7 volt nominal battery to get us to those voltages. Now, when we design our cars and design where the battery packs and modules go, we have to figure out, okay, how much current are we drawing? Where is that current going? How are we going to map that throughout a car? I've seen some really, really shoddy work where people use just undersized cables to do some things. You had a car that was cooking wires for a while.
That's right. Yeah, I had a conversion that was a little secondhand, and you can look at a piece of cable and think, oh, that looks great, 2-aught cable, that's this thick. But with that car and the low voltage system, the current was 1200 amps or whatever it was, and you end up cooking a piece of 2-aught cable. So you got to really do the maths on this stuff and look at how the car is going to be used, because for a short burst that's fine, but trucking down the highway pulling 500 amps will melt a cable like that. So you got to do the math before you buy your cable for sure.
Also, I noticed too, there's, especially since we're kind of new in this industry, as everybody, not just us, but a lot of the people that are doing this now, there hasn't been a real standard set to what we use or what you use or what our competitors use. So there's a lot of different types of cable. You get cable that's with shielding, there's cable that's made for conveyor belts and high flexible use areas, or that's roadworthy. Yeah. So be careful in what you're buying and where you're buying it from. We've seen cable that is designed to do one thing and it doesn't. It's really, really dangerous. And when you're dealing with hundreds of volts, in our case here at Revolt, we got 400 volt systems, and you're dealing with 1500 amps packed behind it, and one of our cars has over 2500 amps sitting behind it, about 3000 amp pack. Yeah. Things could really go badly for you real quick.
At minimum, they will get interesting.
Yeah, we've had things pop. I'm not going to lie. We've had things pop and spark back there a few times. Luckily, we all take safety very seriously around here, so everybody had our glasses on when that firework went off. But it does happen. And so just make sure that when you're looking at power distribution through your vehicles, that's part of your battery management system, is how you're going to manage the power between all of them, especially when it comes to like BMS wires.
Yeah.
I mean, you just wired the whole entire Mustang.
Yeah.
And you plan that. You want to make sure the modules are close. And
yeah, you don't want to be running a bunch of cables in a bunch of different directions. So you're going to map out your whole system before you even pick up a tool. Draw the whole thing out, probably a few times over, and figure out where your looms are going to go so you can get it neat and tidy the first time. You don't want to be pulling a wire out of a loom to make a connection that you forgot about, kind of thing. It'll kind of ruin your day.
So to touch on that point, this plate you see right here is how he mapped out where he's going to put the modules. So now he knows that you're going to have a cable loom here, that goes to this module, to that module, to the battery pack. So it's very important to plan.
Yeah. 10 minutes of plan is going to save you hours of rework.
Yeah, it's splicing into a cable that has 300-400 volts behind it.
No.
Yeah. It's not exactly fun. So yeah, power distribution is one part of this whole battery management system. Also communication. So that basically involves communicating with the battery and the interface between the BMSs and the rest of the system. So like in front of me right here, I have the AEM system. So we have some of their BMSs. We have their VCU 200, which is a vehicle control unit, and their CCU. So it's basically their combined charging unit. So all this basically talks to all these different parts. The VCU is the brain behind this. So what it's doing is it's communicating with the BMS systems to make sure everything's okay. We got a charger over here that may be charging your battery pack. If something were to go wrong, the VCU will catch it and make sure that either turns off charging, slows down charging, speeds up charging, and a bunch of different parameters that you could build in this. Also, if things get warm, this could turn on pumps. It could turn off pumps, turn on fans, chill places,
even.
Yeah, air conditioners. Yeah. But that's the big general picture of battery management. Don't think about cell balancing as just the big piece. It's all this combined. When our car charges, it's wintertime here now, which is not really that cold, but it is chilly. We don't need to really do much for the chilling. It kind of maintains itself. But on a hot day, kicks in fans. Our fluid could be warmer because the charger's heating up a little bit more, and it depends on which kind of cooling loop you have this thing on. So communication between these things is key. How many CAN bus cables have you run through the Mustang now?
We got 5 different networks in the car, 4 being CAN and 1 being ISO SPI. There's a lot of communication. Everything knows what everything is doing. Yeah.
And not only that, I mean, one of the big pieces of the communication puzzle is the user interface, because it doesn't matter what's happening out there if the user doesn't know. And so all that communication loop kind of terminates at whatever the display is, and that's how the end user can actually see, oh, cell 12 is hot.
Yep.
Yeah.
So that's another piece of the communication.
Yeah, and also when I program these things too, I have warning screens that I could trigger at certain events. So if something is getting, to me, I have 3 zones. It's stage 1, 2, and 3. Stage 1 is, hey, there's something that it's not great, but it's here. Stage 2 is some things are getting warm or out of place, or voltages are going, in a certain direction. And stage 3 is shut everything down, stop what you're doing.
Flashing lights.
Yeah, and then
Red lights.
and the screen will tell you that. Literally, I have the screens changed that they will actually just turn red and start blinking at you and saying, hey, trying to get your attention, saying, stop. Whatever is going on, it needs to stop immediately. So those are the 3 stages I like to program into everything I do. Because a lot of times you're going to be in stage 1, possibly stage 2 when you're racing. Stage 3 is like one of those, okay, we need to now take, the car itself can't handle this. We need to take some sort of action, like pulling over and stopping what we're doing in a safe place to make sure that things don't get out of control. A lot of these systems will not stop your car from going up into flames. This is the DIY market. The only real big brother I've seen in this so far is people like AEM. I mean, there's more of them coming out, and I'm not picking one brand right now because we have a lot of different brands on the table here. But as this evolves and as things get bigger and more people start coming into this market with solutions, we'll see more of this integrated type of solution available to us. But up until now, I didn't really see anything beforehand. I mean, you had a balancer, a charger, you had your shunt back there, and then
all different brands.
Oh,
you gotta
yeah,
figure out how to make them talk to
Just
each
a
other.
hodgepodge of parts.
Yeah, and you've been in the CV industry quite a long time. I mean, you've built some pretty cool cars, worked on some big systems, fully integrated, and I mean, what a nightmare.
Man, it gets complicated because you got to figure out if this charger can communicate with this VCU, if they work on the same CAN protocol. It's a mess. So if you can get hold of a system that is all in one and communicates with itself, great. It's going to make your life a lot easier.
Yeah,
Save man hours.
Yeah.
There's not many of them out there, so we're hoping to see more of it out there too. Also, with some of this, communication, make sure your CAN lines are run properly.
Yeah. Oh God, you can chase CAN for weeks because it's not like something's, if you had a short, you could trace it and find, figure out which wire it's on. If CAN doesn't work, it just doesn't work, like dead, and no indication of where that is in your car, front, back, underneath. So yeah, get it right first time.
Yeah, and we'll go into one step here I want to talk about real quick before I jump on to data logging is the types of BMSs real quick. I want to, or should we keep that for later?
You know what? Let's do that in the next segment.
Yeah.
Sounds good. Okay,
Stay
yeah, thanks. So basically data logging. We're kind of going back on everything we're talking about. How are you going to know what's going on unless you log this? You may not be looking at a display, or maybe you don't even have a display that's going to tell you that something is wrong in the car. a lot of times when racing, especially at Bonneville last year, we didn't really have much of an interface to display to the user. Our driver had a red light in front of him, and he had a temperature gauge, 2 of them. And he doesn't really have time. He's doing, 350 plus miles an hour.
Busy.
He's got other things on his mind at 359 miles an hour.
So we did have problems in the car that we weren't aware of until, I went back and I looked at the data logs. I was up until 1 in the morning.
Till the hotel room, yeah.
Well, the first year before you went there was snow.
Yeah, it was well. We stayed in an RV, so literally, Drew and I are asleep, and you hear. I was like, "You got rats in here?" And 2:00 in the morning, he's still, looking at data files to see what happened in the previous 3 runs.
Which is super valuable because you didn't know.
No.
Why isn't the car going any faster? We don't know until you look at the data and you get this information. So
And a lot of that data too. With that particular instance, it was, some of the things we kind of knew that night, and the next morning talking to other professionals in the industry of like, hey, this is what I'm seeing. Why is it doing this? And it took somebody that knew that control system to go, well, here's your problem. It only does that because of this. And I didn't know that at the time. And then the only reason I could actually pick this apart is because I had those data files. The more you log, the better. A lot of these systems now, we use EV controls for a lot of our builds. They have a great data logging system, kicks everything out to a CSV file. So you can open that in like your common Excel spreadsheet, and then you can chart and map stuff. They are great tools for not only seeing what your vehicle is doing, but to troubleshoot things. And also, we're in the high performance era, or over here with the hot rodding stuff that we do. So we're not only trying to catch what the vehicle is doing and how it's working or not working, but we're also trying to see what we could do to make it go faster. What kind of current limits we're running into.
Yeah.
What our batteries could do. So like Bonneville, we had an issue with the battery the first time. We knew what the motors could produce. We knew what the systems could kick out, and all of a sudden, I'm not getting that. And after reviewing the data at night and looking it over and talking to some people, we were able to find, hey, look, you're diving this battery down so far that the computer systems are physically shutting it down.
Yeah.
One good thing about the Tesla large drive unit is it has a lot of protection built on. And I think that's a really, really good thing. With a lot of these OEs, we have to learn from them. They built in this protection for a reason, is to keep people from getting killed or getting hurt severely. So when a certain thing happens, like for us, we had a battery pack out of a P100D in that vehicle, and we're running 2 large drive units at over 300 kilowatts each. That particular battery was not designed to do that. It did it for 15, 20 seconds, and then it drug down the voltage so far that the actual control systems on the motors were shutting the motors down. They're like, okay, hold on a second, you're getting way too far down in the pack, shut things down.
Which is battery management.
Absolutely.
It wasn't in a battery management unit. It wasn't in a BMS, but that's still a form of battery management to consider, that it was limiting your voltage sag.
No, and honestly, that probably kept us from lighting that thing up on fire.
Yeah.
Oh yeah, well, yeah. The battery pack has several top and bottom. It has a plastic plate in between each, and every single battery in the same spot, melted top to bottom, top to bottom, top to bottom.
Because the lower your
throughout
voltage gets, the higher your current gets with the same power. So that thing was cooking.
Well, I kind of want to dive into that a little bit more. I mean, you bring up a really good point, is battery management isn't always...
It's not in a BMS.
Attached to the battery.
Yeah.
I mean, that was on the motor side of things. And thank goodness that, Tesla built in that logic. I mean, it kept us from going any faster, which kind of sucked. But it kept us from getting into some serious issues with fire. If that battery would have caught fire out there, and I want to say this to everybody in this industry, we are under a microscope right now.
Oh, yeah.
If my car would have caught in fire on Bonneville, everybody would have lost.
Black eye for the whole industry.
Exactly. Everybody, you're right, black eye for the, everyone would have looked at us and said, you guys looked like a bunch of idiots. And
well, not only that, you get all like the naysayers are like, I told you this was going to happen, right? So
even if you're not trying to represent the industry, you are.
You are.
Yeah.
I mean, how many times do we hear of a Tesla being caught on fire? Every single time a Tesla catches on fire, it's on the news. Another EV burns down.
You don't hear that with the thousands of ICE vehicles that burn down.
Yeah, and even at the racetrack, a car catches fire, like, check it out.
It's
That's cool.
blowing a piston outside, big cloud of smoke. You go, whoa.
I think at Bonneville, like almost every other run, something's getting thrown out and it catches on fire.
Yeah.
We unfortunately don't have that luxury, and we don't want to do that either because fire does equal heat, and heat kills people. So, also, do you want to talk about? I mean, you've been in fire situations yourself, Snow. Do you want to talk about, how important it is to really mitigate this stuff?
Yeah. So what Eddie B is talking about, and you touch on it briefly, is I have third-degree burns on about 30% of my body, and I can tell you, trust me, you don't want that. And one of the big things that what we're talking about here is like the fire safety. Is the best fire safety is prevention, right? And prevention is partly this battery management system, because the battery management system, if everything's working correctly and it sees that something is going wrong, shuts everything down. You shut everything down, you completely remove the danger, and then that way you don't have to worry about your drivers or crew being in jeopardy. So one of the biggest things I think to take away from this particular section is not just fire mitigation, but safety. And your battery management system is going to be one of your main safety features in your EV, especially a do-it-yourselfer.
Yeah, and before we move on to the next segment here with the data logging, a lot of that stuff you could catch by looking at some of your data files. Like we were able to catch some serious things during our Bonneville runs because we had data logging. If I didn't have that, we would have no way to figure out that we got close.
You're
to
pulling
some
this
serious problems.
Well, I mean, if without the data logging, what we would have done is, and my numbers may not be exactly correct, but we go out, we run 284. And then we go out and we run again 286. And then we run again 290. So if we didn't have that data logging, we would have put more power to an already failing battery and just kept on running, trying to make, more power. And we would end up burning down the pack, which would, in effect, burn down a car that's been on the salt since 1957. So that data logging capacity allowed for troubleshooting and improving. And the second time we went out to Bonneville, we went out with a stronger, stiffer, and more improved pack. And when we did that, I don't know, the world record trophy over there sitting next to you for 359 miles an hour.
Doesn't have my name on it though. That's a different conversation.
I got a Sharpie.
Oops.
But that 359 miles an hour was a result of the one single change was the battery pack.
Yep.
Yeah.
And the battery management system told us the information that we needed to make that change.
Yeah. And also, it could have cost a life too.
Yes.
That is something that when these cells go up, they don't go out. So onto alarms too. We kind of touched on it briefly, but you need to put alarm systems on this BMS. Cold, hot, over voltage, over current. That is extremely important that you give the user some sort of visual, audible, I don't care how you do it, but that's part of a BMS, is you have to be able to tell the user that something is wrong or something is out of range. Because without some sort of alarm system, how the heck is the user even going to know about it? Most of us that drive a car, we've gotten very complacent. We get in our car, put our key in, turn it on, we drive. The only needle we really look at is the one that says full
E or F.
Yeah, and that's it. Like even in my Tesla, I don't even have temperature gauges in there.
Yeah.
I have zero idea except for how much charge I have. That's the only thing they tell me in a Tesla, which I wish they gave us a little bit more. They don't. Whatever. I see they're trying to keep it simple, but they have a really good battery management system, so you don't have to look at it. But I'm pretty sure that if something goes wrong, actually I know this for a fact. My Tesla is kind of a little bit butchered. To say the
It's
least.
highly modified.
It is.
Why don't you throw up a picture, Dan?
Yeah, we'll put a picture of that one up. So I've had situations that it does warn you. And when it does warn you, it throws up a big signal. It beeps at you and says, look, your motor's too hot. That's happened to me a few times in my Tesla because we've put motors in and out of it and there are some air bubbles and I left something unplugged. Right. And it does let you know very quickly that something's wrong. So alarm, huge thing. And a big part of BMS is making sure that the user does know that something's going to go wrong. Because Worst case scenario, you could stop the vehicle, you could get out, and get everybody out safely. Especially as DIY guys, we like to do some pretty crazy stuff. Keep safety in mind. That's a big thing. Anything I missed there with alarming?
That pretty much covers it.
I
Yeah,
think that pretty much covers it.
What do you have for alarms on your bike?
On the bike, there's a big orange light in the middle for if your water pump stops, because that you might not have, the inverter might not have time to sense that the temperature's going up that fast.
Yeah,
so we have a big light for coolant flow, and that's about it.
Yeah, and that's a pretty hefty bike. I mean, it's an 800 pound.
840 pounds?
880.
And what's the voltage on that thing?
480.
Okay.
It's a real strange
Come on,
one.
give us some specs on that thing.
What did we decide? It was 650 pound-feet of torque, 220 horsepower, I think it was.
Mm-hmm.
Zero gear reduction apart from the chain. There's no transmission in it. It is shaft to wheel. So that thing could go pretty good.
How many cell taps on that thing? It's
114. 114S. Yeah, it's a really bizarre one.
Yeah.
But just to go back to alarms, that car you were talking about that I had that was distinctly second-hand as an EV conversion. You're talking about your state of charge. It had a state of charge gauge. It had a voltage gauge. That's not the whole story, because one cell group in that whole pack was negative. Every time it was charged, it was getting dragged up to 5 volts past everything else, and on the discharge, it was so weak, it's getting pushed negative. So as far as I knew, everything's running great because my state of charge looks fine, but it didn't have a battery management system, which would have told me
It didn't tell you
that.
the state of health.
It did not tell me the state of health. It was pretty unhealthy.
So once again, I'm going to keep nailing this every single segment here. This is BMSs are the entire package. Yeah. It's not just cell balancing. I see it all the time. Oh, my balance, are they? I mean, what other things we need to know about? So big thing, alarms, that's huge. The last thing I kind of really want to get into here before the next piece is fire mitigation. And this is something that none of us really talk about, and I think we really do need to talk about. I mean, snow's been through a fire. I've had a house burn down. I live in Southern California. We have a lot of, brush fires out here. I've lost a home with my father before. Heat is something you just don't mess around with. It comes quick, and it could ruin your life in a split second. Do you want to talk about what this stuff is made out of and how you put it out?
Well, in the military, we're taught 4 different classes of fire. You have Alpha, Bravo, Charlie, and Delta. So, and a class Alpha fire is paper. Throw water on it, CO2, or put it out. A class Bravo fire is fuel. And typically what you want to do is it generates a lot of heat, so you want to smother it. AFFF, halon. And I'll skip over to a class Delta fire. Class Delta fire is, magnesium. So you just jettison. There's nothing you can do. If you have one on ship, you throw it overboard. It's the only thing you do. Now, you get to an electrical fire. An electrical fire, which is a class Charlie fire, well, it's a little bit different, but very similar to a class Delta fire. You throw water on it, you make it worse, right? If you smother it, right, you can take away the flame. But if you don't get rid of the heat, it'll just come right back once the source gets oxygen again. So if you have a battery pack that melts down, there's really nothing you can do with it. So if there was some kind of way you could get it out of the car, fine. But if not, you get your driver out of the car, get your personnel away from it. And unfortunately, and if anybody watching this, they're probably into the EVs, I'm sure you've seen a burned down Tesla, because that's what happens. Once it runs away, there's really not much you can do with it.
I forget who we were talking to. There was some kind of fire chief or something. Said, well, what do you do with an electric car if it's burning on the side of the road? And they said, we sell tickets. We stand back and we watch. And there are some systems being developed in some parts of the world. I think Germany has a fire blanket that they roll over the car, and it's a weighted thing. But as far as you, with the DIY stuff, get yourself safe, I think is the takeaway.
Yeah, and also, as we see that the industry kind of move forward, we are seeing things being developed that are safer and safer. Just to talk about it, this is a prismatic cell. They're square. We have our round cells as well. This is something that we kind of start off in the industry is these round guys. We've seen a lot more round cell issues because they're tightly packed. They don't have any room for expansion, and when they go up, it's fireworks. We've seen actually a Tesla pack go up, and it looks like a 4th of July. I've also seen these prismatics, especially the one that I'm holding in my hand, go up, and they make a bunch of smoke and they make a bunch of heat. Now, there was an incident at SEMA last year, that one of the vehicles did have an electrical problem in it. Luckily, it did exactly what it was supposed to do. That pack never caught fire. That pack just made a bunch of smoke, made a bunch of heat. Luckily, that vehicle was designed correctly in a way that the battery pack and everything else was far enough away from everything inside the vehicle, so nothing was flammable touching it. That vehicle got pushed outside. It was taken care of by the fire department. Once again, they did not douse it with anything. I think they put some sort of dry stuff on it for a second or two and realized that it's a battery cooking.
I think it was the equivalent of PKP.
Yeah, so
it's like a phosphorus material. But
but once they figured out that it wasn't, they didn't know what they're doing, and then once they figured out it was a lithium type of battery, they're like, okay, well, we're just gonna put a cone around it, get everyone out of the way, and once again, that was something that could have been really, really bad, but it wasn't. It was actually mitigated correctly. The battery cell technology that was used for that vehicle, it was an off-road vehicle, was the right. It was the right pack.
Yeah, honestly,
Yeah,
it's a pretty.
And I think one of the good things, if you will, to take away from that is you had worst case scenario. An electric vehicle is burning down, right? Pushed it outside, let the pack do its thing, and it was designed in a way that once they finished, the fire was done. He pulled the battery packs out, put new battery packs in, and replaced the damaged component. And I believe they drove that vehicle before SEMA was over.
No, they took it back and they fixed it.
Yeah.
And I think it was 3 days later that vehicle.
Oh, it was 3 days. Okay.
Yeah, they took it out to, I think, Moab or something.
Yeah.
And really good job on that too.
I mean, that would have been a really nasty fire had it been a more volatile material. This is something that maybe it's not the most exciting thing to a lot of people, but to me, it makes the whole thing so much more accessible when you get batteries that are coming along. I mean, this, as far as I know, it was a punctured battery. It was a worst case scenario situation, and it did exactly what it was supposed to do. It vented, it smoked. If it had been an older style battery,
it would have been flames.
It would have been pretty spectacular. So to me, it makes it a lot more.
If it had been a gasoline vehicle,
exciting.
It would have blown up.
it would have blown up.
Yeah, I mean, literally, there was no flames during that whole entire incident.
Yeah.
So, but once again, we're seeing technology get better. We're seeing things evolve. Battery tech is getting better and better. It's not going to happen overnight, but it's going to take all of us to make sure that we keep the reputation of this going the right direction, and we mitigate these things so they don't happen as often. Use the right cell technology. A lot of DIY guys will go into junkyards and get battery packs at the junkyards. I get it. We've done it. We've done it here plenty of times. There really wasn't much on the market for us even up until a few years ago. Now we're seeing actual batteries being developed. I could get cells that are brand new. I could get these things. There are actually some manufacturers here in the United States starting to manufacture battery cells that aren't going to the big OEs, and they are available for people like us. So pick and choose your batteries correctly. Also, if you are going to be using secondhand stuff, make sure you get matched packs. We do see people get a battery that is out of one car, and then another cell out of another car that has had 100 more thousand miles on it. And then your BMSs, and especially your balancing part of the BMS, is going to be working harder. And if you have a BMS system or even a balancing system that can't move the current fast enough, you're going to run into all sorts of problems. So once again, diving into the fundamentals of proper cell placement, management of power distribution. And part of power distribution, to go back to what we were talking about earlier, is to make sure that those cells are all balancing correctly at the right rates. If you're charging and you can't balance the cell fast enough and your system doesn't catch that, well, you got a problem on your hand. You have an overvolted cell or an undervolted cell dragging everything backwards like your car used to.
Yep.
And you didn't even know about it.
No idea.
Yeah. And you did have a balancer on there. You had a way. Did you have a BMS in there? Or
not at the time. No, not when I first got that car.
Oh, okay.
It was distinctly secondhand.
Well, you just completely messed that one up.
Yep.
So, exactly. What not to do.
Yep.
So I think the big takeaway from this section is battery management system is a must for your EV conversion.
Yeah, and just a balancer isn't going to get you by. You want to make sure you have everything. It kind of leads me into kind of the next section, which is we're going to do two little short segments here. Basically, brands and types of BMSs. We are in the infancies of this particular industry. That means there's just not a lot out there. One of the bigger ones we've seen was, we have AEM, we have dilithium, we have the Thunderstruck stuff. And those are, and we have also Orion. Okay.
Orion's a big player in the game. Yeah.
Big player in the game. And a lot of those, they're single modules. Like the Orion BMS is one brain with a bunch of wires hanging out of it. And you wired one of those up. How fun was that?
It's a great system. Don't get me wrong. It's a really well developed and reliable system. But if you got batteries from, back bumper to front bumper, you're going to run 400 volt high voltage wiring from the back bumper to the front bumper, and you're going to run 96 of them if you're running a 400 volt system. So satellites, I've just wired up the Mustang with satellites. It is night and day easier to do it like that. And then you're running communication wise. No high voltage is leaving that group of cells. So that makes life a lot easier.
Yeah, it's safer too.
Yeah. Because if you hit a rock or something, goes up into a wiring loom of this big bundle of wires of high voltage, you got to know about it.
Yeah, and also too with the safety aspect, when you do have satellites and you have a true battery management system with computers on board and fail safes, if something were to go down with the module, you would know back to your alarming system. So most of the types of batteries the balancers that we've seen, we're going to talk about balancers and specifically right here in the BMS, are something called passive. Mm-hmm. So what they're doing is they're taking the high level cell and bleeding that out into heat, basically a resistor. So it's taking all that energy and just basically wasting it. That's called a passive BMS or a passive balancing system. There are two types of balancers. We have active and passive. Unfortunately, I'm going to say this out loud to all the manufacturers here. Everything I've seen come out of the aftermarket or these brands is passive. That means what it's doing is it's taking the high voltage cells and it's basically burning that off into heat. An active BMS would actually take the high voltage of the highest cell and move that into a lower cell. You're not wasting any energy there. You're taking energy out of one cell and moving it out of the other, but I haven't seen that yet. So we have, all these different nice BMSs out there, but they're all doing passive BMS or balancing. I did find some stuff that, believe it or not, is really inexpensive. This is something made by a company called Dally. You can find these things on Amazon all day long for like $25 or $40. They only go up to about 25S. I use this for all my kids' big wheels and the toys that we do around the house. This little cheap thing has an active BMS in it, and it comes with a really cool app. I'm not sponsored. I'm not endorsing this company at all, but I thought it was really, really cool that these guys are doing it right. I can literally take this pack, charge one cell, and watch it move that energy over the next 4 or 3, depending on how I have it configured. So the differences between active and passive is passive, you're basically bleeding out the extra energy from the top cells into heat. Active will actively take the top one and move it into the ones that need it on the bottom. I would love to see this industry adapt that. The OEs are using active BMSs, especially people like Tesla. They're not just pushing that into heat. They're actually moving that stuff around. I have an idea of why I'm not doing it. As a software developer, that's more code to write. And they're probably trying to keep these things fairly inexpensive, but $25. How much were those?
More than 25.
More than 25.
Which, to fight the corner, that's not going to take care of your temperature. It's not going to take care of your battery health, any of that stuff. That is solely a balancer, which for your kids' toys is perfect.
Yeah, exactly. But once again, just one piece of the puzzle here. As we kind of go down that, we're watching all these brands evolve and things get more compact and uniform. Some of the things, like we have Elcon over there, Gray Charger's been using them for years. There are 2 pieces of equipment sitting there, and they're fairly large. One of them is what's that thing?
What? Oh, you did with the charger?
No, the thing in front of you.
Oh, it's a Hoodad.
It's a Hoodad. Okay, so the Hoodad is the DC to DC step down, and behind it is the actual charger itself. The footprint of that's pretty large, and they're 2 separate modules. We're seeing people now take things and make them a lot more compact. Right in front of me, we have this CCU. It does everything those 2 do together in a nice liquid cooled package.
In about half the footprint.
Yeah, I'd say Wow. Yeah, at least half the footprint. And the weight is a lot less too. That has giant cooling fins on it. One thing too with managing your batteries, heat. Where's that heat going? If you're getting rid of heat and you put a charger in your trunk with a bunch of batteries inside of it, probably not a good idea. Remember, a lot of this stuff has to vent off. I really like the liquid cooled stuff because now I could manage where that heat is going. Where if you have a charger that is fan based or has heat sinks on it, and you put that in a confined area, well, you're not going to really pull a lot of heat out of it. So I do like where the industry is going. As I said, this is taking some time, but there are a lot of great products being released, and they're really thinking about it. Dissecting the OEs is a good idea too. When you're looking at how to plan your EV builds and your BMSs, look at the big guys. I mean, they've got it figured out. You know, you got Tesla, Honda, name a few.
Well, every OE really.
Every OE,
at this point.
Toyota,
Yeah.
Ford, Chevy.
I don't think there's anyone who isn't doing it.
Yeah. And they all kind of follow the same exact path, and we should be doing it too. And you know, they put a lot of engineering time into the management of the actual battery systems.
Yeah, they're spending billions on that stuff so that you don't have to.
Yeah. And there's only one part of this entire thing that will catch fire is the batteries. So we got to make sure we manage them correctly. Also, it kind of leads me to our last piece here is proper installation. That is huge. I have seen some of the most rickety conversions, it's awesome because the guys that started this, the DIY guys in the garage were just building stuff to show the world that they can make a car haul butt and really turn some tires and have a really good time. But on top of it, safety. Where are you going to put your things? You got to install your stuff correctly. When we did the Mustang, everything was thought out. Where are we going to run the high voltage, low voltage? Where your CAN wiring is going to go? All that stuff has to be mitigated properly. Your cooling systems. I just talked about where you put your, fan-based chargers. You don't want them in a trunk. You want to put them somewhere that they're going to be, ventilated to the outside atmosphere. So installation is a big part of your battery management because where you place those things is going to be ultimately where they're going to be prone to external shock, crashing,
vibration, fretting,
environmental conditions.
Yeah.
You don't want to put an exposed charger outside the car, under the hood, under the bottom of the chassis. So things like that need to be taken into consideration.
Yeah, and also check your IP ratings, which is basically how water resistant or waterproof something is. A lot of these things are not. Some of the BMSs that we've dealt with are in these little plastic packagings with the connectors just being wide open to basically the elements. Some of the other brands have a nice O-ring seal on it, and I'm pretty sure you could throw that thing underwater and you're going to be just fine. But once again, whatever systems you're using, proper installation is extremely sensitive with this stuff. So it's important to put these things in a place that they are going to be at. Did I miss anything on that?
No, I think that pretty much covers it.
Yeah.
I like the who dad. The who dad. That's probably a question, and somebody's got to ask what a who dad is.
The DC who dad.
Yeah. Well, I would have called it a DC to DC converter. But
Cool. So I guess that wraps it up.
I think it does.
I think that wraps it up. I think the big takeaways we want you to, take away from today's training is one, the importance of a battery management system, and above all, safety. In everything you do, we want you to be safe. We want you to have fun. We want to see whatever projects you guys have out there, but safety is number one, and the battery management system is going to help you keep safe.
There's only one thing in the vehicle that causes fire in EVs, and that's the battery. That's it. Nothing else could catch on fire by itself besides a battery. So treat it like it's the most important thing in the world, and we call it silent death around here too, because it won't let you know. It will just happen.
It really is the heart of the whole car. You kind of got to plan your whole build around the batteries. I know everyone wants to go fast, everyone wants to put the big motor in and get that done, but the batteries really are the bulk of your build.
Yeah, that's the most complicated piece.
Yeah.
Thanks for joining us for today's training, and hopefully you've taken away from this training the importance of a battery management system as a whole, and we look forward to seeing you guys on the street, in the hood, on the racetrack, and definitely at SEMA.
Yeah. Great.
So-
Good wrap up. So
Yeah,
this is the
I
part
do,
we
yeah,
both
that
know
was
each other?
great,
Yeah,
good.
yeah.
So, what do we do after
We go
this?
back to the
Okay.
studio.
Hey,
Studio. This
you know
is the
what?
studio.
I think it went fairly well.
I think it went good.
A couple of stumbles, but that's what happens. We're a lot better at this than we were last year.